Hunting for distant alien worlds is a lot like trying to spot a firefly buzzing around a searchlight miles away. Telescopes like Kepler already proved that Earth-sized planets are everywhere in our galaxy, but finding them was only the first step. What if I told you that the James Webb Space Telescope is giving us our first real opportunity to study the atmospheres of Earth-sized rocky planets? We are moving from simply counting distant worlds to analyzing alien air. And what JWST is revealing about these far-off rocky planets is reshaping our understanding of how rocky planets evolve. Today, let's break down the latest surprises from Webb. How Webb does the impossible. How does Webb actually analyze these tiny worlds from light years away? Transit spectroscopy. When an exoplanet passes between us and its host star, it blocks a tiny fraction of that star's light. For an Earth-sized rocky planet, that dip in brightness is a tiny fraction of 1%. But Webb's real superpower isn't just detecting the planet, it's looking through its atmosphere. If the planet has an atmosphere, its gases absorb specific wavelengths of infrared light. JWST's instruments read this chemical barcode. In favorable cases, Webb can detect molecules like water vapor, carbon dioxide, or methane. What was the big surprise? One of the first Earth-sized rocky planets observed by JWST was LHS 475b, located about 41 light-years away. Size-wise, it's practically a twin of Earth, 99% of our planet's exact diameter. Scientists weren't expecting another Earth. With a 2-day orbit around its star, LHS 475b was clearly a scorched furnace. But they wanted to know whether such a small, rocky world could still hold on to an atmosphere at all. The data brought a fascinating reality check. Webb's observations suggest that the planet may have little or no atmosphere, or perhaps an extremely dense carbon dioxide atmosphere like Venus. It showed us just how hard it is for small planets orbiting highly active red dwarf stars to keep their protective air layers intact. The TRAPPIST-1 Mystery. The real detective story unfolded in the famous TRAPPIST-1 system, a miniature solar system hosting 7 Earth-sized rocky planets, 3 of which sit right in the habitable zone. Astrophysicists started by examining the innermost world, TRAPPIST-1b, to see if it managed to shield itself against stellar radiation. Webb measured its thermal emission. The verdict? Webb found no evidence of a thick atmosphere. On the day side, temperatures reach a scorching 230 degrees Celsius, 450 degrees Fahrenheit. While a paper-thin atmosphere hasn't been 100% ruled out, it's looking increasingly like a bare rock. This finding raised a fundamental question. Can rocky planets orbiting red dwarfs, the most common stars in the universe, actually retain substantial atmospheres? Or do stellar flares strip them naked over time? Lava oceans and vaporized rocks, 55 Cancri E. So if cool, rocky planets often turn out to be bare rocks, does any rocky world hold on to an atmosphere? Well, JWST gave us an extreme answer with a super-Earth named 55 Cancri E. This planet is a living nightmare. It orbits so close to its star that its surface is a global ocean of molten lava, reaching temperatures over 2,000 degrees Celsius, 3,600 degrees Fahrenheit. Astronomers expected this hellscape to be stripped completely bare. But Webb measured its thermal emissions and found something incredible. The planet wasn't as scorching as it should be on its day side. Heat was being redistributed. JWST detected signs of a thick atmosphere rich in carbon monoxide and carbon dioxide. Out on 55 Cancri E, the lava ocean is actively bubbling and outgassing, literally evaporating rock into the sky to continually rebuild its own atmosphere. It proves that even extreme rocky worlds can possess thick air, provided they have a powerful geological heat engine underneath. What this means for the search for life. The big takeaway from Webb's recent discoveries is clear. Being Earth-sized just isn't enough. While there might be billions of rocky worlds out there, retaining water and a stable atmosphere is a delicate cosmic jackpot. Does this mean we're alone? Not at all. JWST is just getting warmed up. Next on its target list are planets further out in system habitable zones, like TRAPPIST-1 and F, which are among the most promising places to search for potentially habitable conditions. Every rocky planet Webb studies is another piece of the puzzle. Some worlds disappoint us, others surprise us. But each one teaches us a little more about what truly makes Earth so special. Do you think Earth-sized planets around red dwarfs can really keep their atmospheres, or are we looking in the wrong places for life? Drop your theories in the comments below, hit that subscribe button, and I'll see you in the next one. Thanks for watching, and keep looking up.